All right, so 7.2, part 2 is on antidifferentiation by substitution. Okay, this is one of the most important sections that we're going to do this semester, so you will use this all of the time. All right, so it says when we learned derivatives, we learned an important rule called the chain rule. So you remember when we had like things under a square root or, you know, like something, a bunch of junk raised to the 5th power, we'd let that part inside the parentheses be our inside part, so we'd always do the derivative of the inside at the end. Do you guys remember? So we have something very similar to integrals, which is called the substitution rule. You might also hear it called u-substitution. Basically, you need to decide what to set as our u, similar to how it was with the chain rule. It's usually the inside part, and then consider what du is. So on number 1, we have the integral of 2x times the square root of 1 plus x squared dx. All right, so we're going to change our variables from x into a new variable, u. So I'm going to say my u is equal to the inside part, 1 plus x squared. So some of these first problems are going to be like this, where it's very obvious what you should set your u for. The later ones are going to be a little bit harder. All right, du, it's kind of like differentiating implicitly. So the derivative of 1 plus x squared is just 2x, and we write dx next to it. Okay, so the part that I'm circling in red, that is now the square root of u. But when I'm integrating, I don't want dx because I want this new variable. I want du. So if you notice, you have 2x dx. That is du, right? Du is 2x dx. So the blue part is du. So what we have is the integral square root of u du. So the whole 2x dx was du. Okay, this is much easier to integrate. Square root of u, well, that's just u to the 1/2, right? So when I integrate it, I add 1 to my power, so I get 3 over 2. And I do 1 over 3 over 2, which is the reciprocal. So you always take the reciprocal of the power, 2/3, plus c. But then we're not done, so what do I have to do next?
Put it back into x.
Yeah, our original was an x. You need your final answer to be an x. So your final answer is 2/3, 1 plus x squared raised to the 3 over 2, plus c. That's it. Okay, this is called the substitution rule, or u-substitution. So when you see it all written out, it looks very confusing, but basically you let your u be some kind of function with only x's, so that it's in the form f of u, right? G of x was u. G prime is, well, G prime dx is du. So it's f of u du. All right, so it says sometimes you'll have constants that you'll need to pull out before they're in that substitution rule form. So I'll show you what I mean by that. So this first example, so again, it's pretty obvious what you should let u equal. So u is that inside part, x to the 5th minus 4. So du is 5 x to the 4th dx. So when you look at your original, this is sine of u. But then you have extra stuff. You have x to the 4th dx, which is almost what we have for du, but what do we have in addition? What else do we have? We have that 5. So what can I do? Yeah, just divide by 5. So we're saying that 1/5 du is equal to x to the 4th dx. So the x to the 4th dx is now replaced with 1/5 du. Okay, so the way that it is you have your sine of u times 1/5 du. But whenever I have times anything, I just pull it out to the front. You can always pull numbers out to the front of your integration sign, right? So you have 1/5 integral of sine of u du. So basically, if you have a number out in front of your du, just pull it out in front of the integral sign. Okay, so when I integrate, I get 1/5. Is it cosine or negative cosine? Negative cosine plus c. Now, a lot of people ask, why don't you put the plus c in with the negative cosine? Because when you integrate this, you get negative cosine plus c. Plus c is plus a constant no matter what. So we always just tack it on at the very end of the problem. You know, we don't adjust it at all. It's always just plus c. Because even if I had plus 1/5 c, that's still a constant, right? So we just leave it as plus c at the end. Okay, so I get negative 1/5 cosine of x to the 5th minus 4 plus c, and that's your answer. Okay, the next one, again, it's pretty obvious what you should let u equal. So u is the inside part, 4x minus 5. du is 4 dx. All we have right now is this square root of u, and all I want is dx. So I'm going to divide by my 4. So I have 1/4 du equals dx. So I have my 1/4 out front, and then du. So I've now replaced everything. So when I integrate, u under a square root is u to the 1/2. So you add 1 to the power, so it's 3/2 with the 2/3 out front. You still have your 1/4 out front plus c. So you get 2/12, which is 1/6 u, so 4x minus 5, to the 3/2 plus c. Okay, you guys feeling pretty good about these? All right, how about you guys try number 3 and 4? So try 3 and 4, and I'll walk down and check. Okay, so a lot of you guys are having trouble with number 3, so I'm going to show number 3 up here. Oops. Okay, so number 3, you have x over the square root of 1 minus 3x squared. And you're going to let u be the inside part. So u is 1 minus 3x squared. It's the part under the square root. du is negative 6x dx. Now look back at your original problem, and you say, okay, well this part right here is the square root of u. But then all of a sudden you have this other stuff that's left. You have x dx. So you need to think, how do I get rid of my x dx? How can I replace it with u's? So when you look over here, you have x dx. You just have a negative 6 as well. So divide by negative 6, you get negative 1/6 du equals x dx. Right, so that's now replacing everything in your problem, because now that x dx is negative 1/6 du, and the bottom part was square root of u. So you have 1 over the square root of u, du, with a negative 1/6 out front. Okay. A lot of people in my first class were trying to integrate this. So this is what they were doing. They're saying 1 over 2/3 u to the 3/2. Okay. You cannot do that. You cannot just integrate the top and integrate the bottom. It's kind of like, you know, when you took derivatives, you couldn't take the derivative of the top and the derivative of the bottom. That would not be using the quotient rule, right? Yeah, unless you're using L'Hopital's rule, it's true. Okay, so we can't do that. So I would rewrite it as u to the negative 1/2. Negative because it's on the denominator, 1/2 because it's under square root, du. So now when I integrate, I have negative 1/6. I add 1 to my power, so it's u to the 1/2. And what number do I have out front? 2. I ran out of room. So you get negative 1/3 u, which is 1 minus 3, sorry, I forgot my plus c, negative 1, or 1 minus 3x squared plus c. Nope, because it's 1 over 1/2, the new power.
What?
Yeah. Like if I had x squared, it's x to the 3rd with a 1/3 out front, right?
Right.
It's the new power that you're putting down here. It's 1/2.
It was negative 1/2, now it's positive 1/2.
Yeah.
Right. You added 1 to the power.
What it was before doesn't matter.
Should there be a 1/2 after the parentheses of the
Yes. So Morgan's right. There is a 1/2 here.
Well, it does, but you don't use that. So.
All right, so number 4, so you have sine of 4x dx, so just let u be 4x. So du is 4 dx. So you have sine of u, but then you want to get rid of the dx part. You want to replace it with du something. So it's 1/4 du equals dx. So I have 1/4 du. All right, integrate. You need negative cosine of u, right? So I have negative 1/4 cosine of u plus c. So it's negative 1/4 cosine of 4x plus c. Now a lot of you guys are going to get really good at these ones, like sine of 4x, cosine of 8x, something like that. You're going to be able to do these really quickly, and it's because you're going to know, you're just going to think of the opposite. You're going to think, well, what do I take the derivative of in order to get sine of 4x? In order to get sine of x, you'd need negative cosine, so that would give you the first part, negative cosine of 4x. But then if I'm taking the derivative of negative cosine of 4x, you need times 4. So the integral, you have to undo it with a 1/4. Okay, so a lot of you guys are really good at that thinking, like with the reverse. So you should, by the AP exam, you should be able to do at least these ones without doing a u-substitution. You should just think about it. Okay? All right. So those are all indefinite integrals. So we did not have numbers on our integral sign at all. We didn't have what's called limits of integration, the a to b part. Okay, let's do ones where we have numbers. So this is when evaluating definite integrals, you can do 2 different things. So the first thing you can do is change the integral into u and du, and then convert back to x before plugging in your limits of integration, so your a to b. The second thing you can do is change to u and du, but then also change your limits of integration. So change those so they're now u values, not x values. Okay, so I'm going to show you both ways, and you can kind of decide which one you want to do. So example number 1. So method 1 is just converting to u du and then plugging x back in before. So I'm just going to do a indefinite integral first. I'm not going to write all the limits. So if I was doing this, I would let u be 2x plus 1. My du is 2 dx. So I get 1/2 du equals dx. So I have 1/2 the integral of square root of u du. Okay, this is u to the 1/2, so when I integrate, I get u to the 3/2 with the 2/3 out front. I still have my 1/2 out front. And then you'd have your plus c if it was indefinite. So in other words, you get 1/3, u was 2x plus 1 to the 3/2 plus c. So once you've shown all that without the numbers, well, now let's go to where we have the numbers. So my limits of integration are 0 and 4. So that means I would have 1/3, that's a 3. Still not pretty. 1/3 times 2x plus 1 to the 3/2, and you're going from 0 to 4. Those are x values that you're plugging in. So you get 1/3. When I plug in 4, I get 2 times 4 plus 1, so 9 to the 3/2, minus 1/3. 2 times 0 plus 1 is 1 to the 3/2. You remember from algebra 2, if you have 9 to the 3/2, the bottom number is your root, so we have a square root. The top number is your power, so you raise it to the 3rd. So square root of 9 is 3 to the 3rd is 27. So you have 1/3 of 27 minus 1/3 of 1, so you end up with 26/3. So that's the first way. Okay, the second way is the way I usually do. So, you guys are going to have preferences. It doesn't matter which way you do this. I don't care. So method 2. Method 2, I write 0 to 4, square root of 2x plus 1 dx. And you do the same u substitution. You do 2x plus 1, du is 2 dx. So you get 1/2 du equals dx. So you set it up and you have 1/2 square root of u du. But now I'm integrating with respect to u, so my limits of integration are going to change to u values. So what I write is u of 0, right, 0, and u of 4, and I find what those are equal to. Okay, this is a function. It's saying you're plugging in 0 for x, and you're getting a u value out. So what am I plugging it in for? Yeah, 2x plus 1. You're plugging 0 in for x, so you get 2 times 0 plus 1. So you get 1. You're plugging 4 in for x, so 2 times 4 plus 1. So you get 9. So you're really going from 1 to 9 with the u values. Does that make sense? So when you integrate, you get u to the 3 over 2 with the 2/3 out front, 1/2 out front, and you're going from 1 to 9. So you get 1/3 u to the 3 over 2 from 1 to 9. Do you see you're at the exact same spot as this? Because now when you plug in 9, you get 1/3 of 9 to the 3 over 2 minus 1/3 of 1 to the 3 over 2, which is the exact same thing, so you should get 26 over 3. So which one do you guys like, second or first? The first?
No.
Second? Doesn't matter. I mean, people have preferences on this, so it's whichever one you like the best. So the only thing that gets tricky with the first one is when you have a really long u, like u equals a really long polynomial, and then you have to go back and write that long polynomial in, you know. All right, so number 2. So you can pick whatever method you like. Doesn't matter. I'll let you guys try it first before I show you. All right, I'll do method 2. Okay, so u is equal to 1 minus 4x. So that way when you take the derivative, you get negative 4 dx. So negative 1/4 du equals dx. So I saw a couple of you when I walked around, you had u equals 1 minus 4x squared. And the problem that happens when you have that is the derivative is 2 times 1 minus 4x to the first times negative 4. So basically you're still going to have an x. And what you had left did not have an x, right? It was just dx. Okay, so that would not have worked because you would not have been able to put du in. All right, so this one you have 1 to 4 dx over 1 minus 4x squared. Okay, so you're now going to have negative 1/4 out front. 1 over u squared du. Now you can write the du on the top like they did with the dx. You'll see it either way. Doesn't matter. Okay, so what this is negative 1/4 the integral of u to the negative 2 du. So when you integrate, you need to add 1 to the power. So you're going to have u to the negative 1. And then you have 1 over negative 1 out front. So you have negative 1 out front. And then plus c. Oh, wait. I forgot my numbers, didn't I?
Yeah, I was like,
I'm doing method 2. Yeah, so your u of 1 is 1 minus 4, so negative 3. And u of 4 is 1 minus 16, so negative 15. So you're going from negative 3 to negative 15, which looks weird because usually it's the a values less than the b.
No, I see. There's negative 1. Negative 1.
You're using the new power.
Yeah.
Alright. So you have 1 over negative 1. I think you are thinking like the derivatives where you're using the old power. So negative 3 to negative 15. Okay, so you get 1/4 u to the negative 1, and you're going from negative 3 to negative 15. So you have 1/4 negative 15 to the negative 1. minus 1/4 negative 3 to the negative 1. Lots of fractions, so 1/4 times 1 over negative 15 minus 1/4 times 1 over negative 3. You end up with negative 1 over 60 plus 1 over 12, which is 5 over 60. So 5 over 60 minus 1 over 60 is 4 over 60, which is 15, or 1 over 15. So you get 1 over 15. Okay. Did you guys get the answer? Good. All right, so negative what? Positive 1 over 15. All right, so sometimes it's not so clear cut, like what u should be. I think on number 2, you know, you could have had 1 minus 4x or 1 minus 4x squared. Maybe you guys got confused on those ones. But there are some that are even more confusing because they don't have like parentheses, they don't have square roots. It's very hard to see what the inside part is. Okay, so that's like number 1. So number 1, we have sine squared 3x, cosine of 3x, dx. So you have to think about your u. So if someone's saying 3x, so if u equals 3x, if it's sine of 3x, yeah, if u is equal to 3x, then that's not really helping us, because then we still have sine squared u cosine of u with a 1/3 out front. And I don't know how to integrate that. Sine of 3x, do you guys think sine 3x? So let's try that. So let's see. So if I have u equals sine of 3x, I want to know if my du is in the problem. So the derivative of sine of 3x is cosine of 3x times 3 dx, which we have, cosine of 3x dx. That 3, I'm just going to have 1/3 du. So if we had sine of 3x, that means that this part is u squared. And this other part was the du. Well, 1/3 du. Make sense? Okay, so we're integrating 1/3 u squared du. So I get u to the third with a 1/3 out front, with another 1/3 out front from the original 1/3, plus c. So 1/9 sine of 3x cubed plus c. You can write the cubed right next to the sine part too if you want. It doesn't matter. That's it. Yep, not bad. Okay, the next one is what I always hated when I was in my calc class because it's not very straightforward. I mean, you don't see the du part. So when you're thinking about what to let u equal, you see the inside part, the 2x minus 1, and that is exactly what you should let u be, 2x minus 1. But the problem is when you do du, you get 2 dx, which there's still an x there. So it's like, how do I get rid of that x? So you have 1/2 du equals dx. Basically, all we need is for all of our x's to now be u's. So you can change that x to something with u, right? So if you look at your original, like u equals equation, and solve it for x, like get x by itself, it's not bad. You get u plus 1 equals 2x, so u plus 1 over 2 is equal to x. So we replace x with that. It's okay because x is being replaced with the u plus 1 over 2. The square root of 2x minus 1 is being replaced by the square root of u. dx is being replaced with 1/2 du. So now we have everything in terms of u. So it worked out. Okay, now what? How are we going to integrate something like that? Yeah, let's pull the other 1/2 out, so I have 1/4.
And then multiply all the terms.
So I have u plus 1, and then I have a u under a square root, so that's u to the 1/2. Does that help?
U 1? It would just be u. I'm confused.
We just brought this 2 outside with the other 2.
Oh, I see. And that's just the numerator left over.
So now if I have u to the 1/2 times u plus 1, you just distribute it in and you add your powers. So if I have u times u to the 1/2, that's u to the 1 times u to the 1/2, you add your powers, which is u to the 3/2. So we get 1/4 out front, u to the 3/2, plus u to the 1/2 du. You with me? Okay, now we integrate. Guys, this is not bad. It sounded pretty negative to me. So you get u to the 5/2, right? You add 1 to the power. It was 3/2 before, so adding 1 gives 5/2. Put a 2/5 out front. Plus u to the 3/2, put a 2/3 out front. And then plus c on the end. So your final answer. You can't leave it as u, no. The 2 and 4 cancel or reduce, so you get 1/2. So 1/2 times 1/5, so 1/10. So it's 1/10 2x minus 1 to the 5/2 plus 1/4 times 2/3 is 1/6. So 1/6 2x plus, minus 1 to the 3/2 plus c. If you guys think this is bad, you're not even in store for integration by parts, which is like next section. So you'll be fine. You can do this. All right, so that's your answer. All right, so next one. So I have 1/3 secant squared 8x dx. What do you think we should let our u be on this one?
Tangent of 8x.
Nope, not u.
Secant squared 8x.
Nope.
Wait.
Tangent. That's
Tangent of 8x. Secant squared.
You guys, a lot of you guys are stuck on the tangent thing. I like that you're thinking tangent.
You integrate, you get tangent of u.
If you integrate, you get tangent of 8x, right?
2√2.
So how about we just let u be 8x? So u is 8x. Because du is then 8 dx, so it's 1/8 du equals dx. Okay, so what we have is 1/3 all the way out front from before, 1/8 out front, and you have secant squared u du. So you say, what do you take the derivative of in order to get secant squared? Tangent. So you have 1/24 tangent of u plus c. So 1/24 tangent of 8x plus c. And that's it. Okay, number 4 is very similar to number 2. So number 4 is one of those ones where you have to solve for x. So go ahead and try it. So try it first. Okay, so how'd you guys do on number 4? Pretty good? All right, so you should have u equals, guys, u equals x minus 2. Guys, Lee, Tarek. So you should have u equals x minus 2, so du is dx. So when you're looking at your integral, you have the square root of u and the du part, but now you still have this x plus 2 in there. So that's what I was saying you need to solve. Morgan, can you close that door, please? Yeah, so what I usually do is I look at my u and I say, I don't want x minus 2, I want x plus 2. So what do I have to do to both sides of the equation to get x plus 2? I would need to add 4 to both sides. So I'd need u plus 4 equals x plus 2. But in the first class they were saying they don't like that way, so that's fine. You can just solve for x like we were talking about. when you solve for x, you get u plus 2 equals x. So then in your problem, instead of writing x, you write u plus 2, right? The other plus 2. X was u plus 2, and then yet another plus 2. You got it?
2 and 2.
Yeah.
22.
It's okay. So you get u plus 4 times u to the 1/2 du. You have to multiply in. So you end up with u to the 3/2 plus 4u to the 1/2 du. So when you integrate, you get u to the 5/2 with the 2/5 out front, plus, I just leave the 4, you get u to the 3/2 with the 2/3 out front, plus c. So you get 2/5 u is x minus 2 to the 5/2, plus 8/3 x minus 2 to the 3/2, plus c. So how many of you guys got that?
I did.
Just Evan? Oh, 2, 3, 4,
This
5.
guy.
All right, good. This guy. All right. Next two. So this one looks like it would be similar, just because you have the x plus 2 out front, but this is actually a little bit easier. You don't have to solve for x in this one. And here's the reason. When you let your u equal x squared plus 4x minus 3, and you take the derivative, you get 2x plus 4 dx. Yeah, that's almost what you want, right? Almost what we need. Because what we need is x plus 2. So Alex just said, oh, take a 2 out, right? Divide by 2 on both sides. So that means that we would have 1/2 du equals what we want, x plus 2 dx. So when we integrate, we have 1/2 and the du, replace the x plus 2 and the dx, and then we have the square root of u. So we get 1/2. Square root of u is u to the 1/2, so we get u to the 3/2 with the 2/3 out front, plus c. So it's 1/3 x squared plus 4x minus 3 to the 3/2 plus c. And that's it. Box it. All right. Okay, the next one. This one's a little bit harder, so let's kind of talk it through. I think you guys could totally handle this one. You can see what u would be, right? X minus 4. So when you take the derivative, you're not going to get that x squared that you need, right? You're just going to get dx. So what do? Yeah, solve in terms of x, plug in, blah, blah, blah. Okay, so if I solve for x, I get x equals u plus 4, and we want x squared. So x squared is u plus 4 squared, which is u squared plus 8u plus 16. So that means that x squared is u squared plus 8u plus 16. The bottom is square root of u, and then we have du. Do you know how to integrate that? You could raise it up. Morgan's saying you could multiply the whole numerator by u to the negative 1/2. You could do that, right? Or basically that's the same as bringing this u to the 1/2 in to each one, right? So this is u to the 1/2. So I'll write that step so you can see it's u to the 1/2. And then you're going to subtract your powers. So you're going to have u to the 2 minus 1/2, so 3/2, plus 8. This is u to the 1, so when you subtract your powers, you get 1/2, plus 16u to the negative 1/2 du. So when you integrate, u to the 5/2 with the 2/5 out front, plus u to the 3/2 with the 2/3 out front, plus u to the 1/2 with a 2 out front. It's a long answer. So you get 2/5. U is x minus 4 to the 5/2 plus 16/3 x minus 4 to the 3 over 2 plus 32 x minus 4 to the 1/2 plus c. And that's it. Okay. What makes things really interesting is if you wanted to check your work and you went from this step, I know. If you went from this step and you tried to get this again, that would be kind of hard because you have to get common denominators. I mean, it'd be pretty messy. So, I mean, it would work, but. All right. So these will take us 2 seconds. So symmetric functions. Think of the most basic even function you can think of. X squared. So think about x squared and what it looks like. If I was integrating from negative a to a, that would be finding the area from negative a to 0 and then 0 to a, right? Yeah, it's the same as if you had just gone from 0 to a, so only that piece, and then doubled it, right? Ends up being the exact same thing. Okay, so sometimes it's easier to start from 0 for your limits of integration. So we're saying that you could just go from 0 to a and then double it. All right, if f is odd, here's an odd function, x cubed. Let's say I go from negative a to a. Yep, it's 0 because this piece is a negative integral. This other piece is the same, but it's positive. So they cancel each other out. So if you can show that something's odd and you're going from negative 7 to 7, it cancels. You get 0. All right, so that can really help you out on some free response question, or not free response, on some multiple choice questions. So let's try some of these. So let's say you had to find this, negative 3 to 3, and you notice that all of the powers are even, right? 2 is really 2 times x to the 0. So all of the powers are even. So that means the whole polynomial is even. So that means you could just double the integral from 0 to 3, x to the 4th minus 3x squared plus 2 dx.
Why would it be 0 to 3 not negative?
Because we're using this rule up here. So if it's even, instead of going from negative a to a, we just do from 0 to a and then we double it. Because they're the exact same values. They're both positive integrals that are the same number. Okay, it's symmetric. All right, so what makes that nice is plugging in 0 is always a lot easier than plugging in negative 3. So we get 2 times, when I integrate, it's x to the 5th with a 1/5 out front, minus x to the 3rd, plus 2x, and I'm going from 0 to 3. So I get 2. When I plug in 3, I get 1/5 of 243, minus 3 cubed is 27, plus 6. And then this is what I was saying, when you plug in 0, 0. So that makes it a lot nicer than plugging in negative 3. So you end up with, I think the first class had 55.2. So 55.2. All right, now number 2, you're going from negative 3 to 3, so that's kind of, or negative 5 to 5, so that's kind of a clue. Hey, let's see if this is even or odd or anything like that, so I could shortcut it. So in this case, it's odd, right? X is x to the 1st. So what's my answer? 0, that's it. So if you drew that function, it would be symmetric about the origin, like that. And you would be able to see you have a negative area, a positive area, they're going to cancel each other out. Oh, and 3, do you guys have that one on yours? Okay, what's it say? Tangent of x over
1 plus x squared plus x to the 4th here.
Okay, and it's going from?
Negative 1 to 1.
Okay. All right, so in the first class, we talked about sine and cosine, first of all. So sine, think of its graph. Odd or even? Odd, clearly, right? Positive, negative, they cancel each other out. Cosine of x.
Even.
Odd or even?
Odd. It's even. Even, Steven.
Even. Right? like a parabola, it's symmetric about the y-axis.
Cosine of negative 1
Why is that even?
Because it's like a parabola, it's symmetric across the y-axis. That's what it means for even. All right, so what about tangent?
It's odd.
It is odd. Can you guys remember what the graph looks like? Yep, something like that. That actually goes through 0, 0. Mine kind of got off. Yeah, it looks like that. It's odd. Jimmy's getting there. Are you guys getting there? So this in our case is odd, and this one's even. So usually people are like, oh, so then I actually have to integrate odd over even. But odd over even is just like tangent. Tangent was sine over cosine, right? And it ended up being odd. So it's odd. So this equals 0. Okay, if you didn't know if it was odd or even, you could always try to graph it and see. You could maybe plug in some different x values. If something's going to be odd, right, it's if you plug in a certain x value, you get the opposite y value as if you plug in negative x. Right, you get one's positive, one's negative. You try that. Okay,